Hi! We have been asked to cover Cramer's rule in section 2.3 of the Willy Plus online linear algebra course, but I thought first I would cover question number 1 and kind of give you a background on determinants. So in question number 1, we're given matrix A, and we're asked, use determinants to decide whether the matrix is invertible. Enter the value of the determinant and select the correct answer from the drop-down menu. And here are our correct answers, but I'm going to show you how to do that. So in theorem 2.3.3, excuse me, a square matrix A is invertible if and only if determinant A is not equal to 0. So here's our matrix, and using the checkerboard array that we were shown in section 2.1, we can just calculate the determinant. I decided to use row 2 simply because the numbers are simple. I have a 1, 1, and a 0. You can use 1 or 3, but for me, I just thought number 2 was simpler. Easier. Sorry. So we end up with a -1 based on the array. So a -1 here, and I used the cross product of row 2 and row 3. So we ended up with this row is canceled out. We end up with 2 remaining rows. Then plus the second factor, 1, and the cross product of the other sections in the matrix. And then the third factor is a 0, so anything multiplied by 0 is just a 0, so I didn't write it in. If you choose to, you can. Then you calculate out your cross products, and we end up with a determinant of -14, which is not 0, and therefore it is invertible. So that's number 1. Really simple, really straightforward. So I'm going to show you number 8 using Cramer's rule. It says apply Cramer's rule to solve this system of equations, and these are the equations we were given. X sub 1 minus 3x sub 2 plus x sub 3 equals 1. 2x sub 1 minus x sub 2 equals -2. 4x sub 1 minus x sub 3, or 3x sub 3 is equal to 0. And as you can see, we've gotten the solutions here, but I'm going to go ahead and continue on and show you how to do that. Under theorem 2.3.7, Cramer's rule, if Ax, which is the sum of all the x's, is equal to the matrix B, is a system of n linear equations in n unknowns such that the determinant does not equal 0, then the system has a unique solution. This solution is, and here are the formulas that we are going to use to solve this problem, where Aj is the matrix obtained by replacing the entries in the jth column of A by the entries in the matrix B. And here's your solution matrix. And you can read the little blurb there about Gabriel Cramer, who originated this. So using Cramer's rule, here is our formula, and we have set up our matrix A and our solution. I'll come back and I'll explain these in a second. So we've discovered the determinant as we showed before. I chose on this problem to use the third row, so I ended up with 4, -0, and I had a -3, which is a positive -3, based on the checkerboard array. And then I used the cross products of the remaining rows. So my first one, I will have these sections here. The second one is a 0. So in the third one, we have the cross product of these numbers right here. And we solve that, we get a determinant of -11. Okay, so I did not show it here. I will go back to here. So my A sub 1 matrix, I replaced the first column with my B matrix. And then the second and third columns remain the same. And we solve it the same way. I chose to use the third row, 2 zeros, definitely the easiest way to go. So just a -3 times this cross product, I got a 21 as a determinant of A sub 1. So then A sub 2, you take your B matrix and you replace the second column and solve it the same way. So you can see I chose the first row, which is all ones, and I ended up with a determinant of 20. For the A sub 3, I replace my third column with my solution vector, or solution matrix, and solve using the third row again, which is now primarily zeros. So I just have the one to solve, and I ended up with 28. Then going back to our formulas, A sub 1 will be the determinant of A sub 1 over the determinant of A. X sub 2 will be the determinant of A sub 2 over the determinant of A. And so on. A sub n is the determinant of A sub n over determinant of A for any problem that you have. So to get our solution, whoops, didn't go far enough. I took my X sub 1 and I put my determinant of A sub 1, which was 21, over -11. That's your solution. And you do the same for A sub 2, A sub 3, and these are our solutions that we saw back in the original problem. And that's all there is to it. It's really simple, and thank you for joining me. Bye.